Orange peel remains one of the most pervasive and misunderstood defects in solvent-borne automotive coatings, particularly in high solids base coats and clear coats. From an RD&I and OEM perspective, orange peel is not a simple cosmetic issue, but a symptom of the dynamic interaction between solvent evaporation, wet film rheology, surface tension, and the timing of gelation. Immediately upon application, the coating begins to lose solvent from the surface, while the internal film retains some mobility. This creates a gradient in viscosity from the surface to the interior, and if the surface forms a skin too quickly, flow from the underlying wet film is restricted. The result is a wavy, dimpled surface that resembles the skin of an orange, where reflections appear distorted under directional lighting or reflection tunnels. Correctly identifying this defect is essential, as misdiagnosing it as a spray problem alone often leads to unnecessary equipment adjustments, wasted material, and repeated rework. The root causes of orange peel can be divided into formulation, process, and environmental factors. On the formulation side, viscosity plays a critical role. High-low shear viscosity prevents the wet film from leveling under surface tension before gelation occurs, while improper solvent blends accelerate skin formation. Fast solvents evaporate quickly from the surface, reducing open time, whereas insufficient medium and slow solvents hinder internal flow, locking the texture prematurely. The total solvent balance must be carefully designed to match the expected film thickness, ambient temperature, and relative humidity. Excessive dry film thickness exacerbates the problem because the top layer can skin while the inner film still contains tail solvents, creating trapped pockets of differential flow that manifest as texture. Additives, such as flow and leveling agents, are often used to fine-tune surface mobility. Polysiloxane-based or acrylic-modified surfactants reduce surface tension gradients and promote flow, but they must be dosed very carefully, typically in the low tenths of a percent. Overdosing can create secondary defects like craters or fisheyes, while underdosing provides no measurable benefit. From an RD&I standpoint, additives are considered fine-tuning tools, not primary corrective measures. Process parameters are equally critical. Spray equipment, atomization air pressure, nozzle selection, gun distance, and travel speed all influence droplet size, deposition uniformity, and wet film flow. Improper atomization may result in larger droplets that take longer to coalesce, reducing leveling efficiency. The flash-off period, the time allowed for solvents to evaporate before entering a bake or oven, is a key lever. Moving the panel into the oven too quickly forces rapid surface skinning before internal flow can smooth the film. Conversely, extending flash-off inappropriately can reduce production throughput, so careful adherence to technical datasheet (TDS) recommendations and seasonal adjustments for temperature and humidity are necessary. OEM plants often use temperature-controlled pre-flash booths or slow reducers during hot weather to extend the open time and allow the wet film to flatten fully. Film thickness, or DFT, is another primary contributor. A thin film may lack the volume to create sufficient surface flow, while a thick film increases solvent retention beneath a quickly skinning top layer, enhancing the risk of orange peel. Viscosity control, both at low shear during flow and under high shear during spraying, is essential. Kinematic and dynamic viscosities must be tuned to ensure proper atomization and wet film leveling. Modern RD&I practices often include real-time viscosity monitoring and spray testing to confirm that the coating maintains the correct shear-dependent flow characteristics throughout the application window. Minor deviations in viscosity caused by temperature shifts or improper mixing can push a marginal formulation into visible orange peel territory. Environmental conditions amplify or mitigate these formulation and process effects. Booth temperature, panel temperature, and relative humidity dictate the rate of solvent evaporation and, therefore, the window available for leveling. Warmer air or panels accelerate surface evaporation, reducing flow time, while cooler conditions increase viscosity, limiting wet film movement. Experienced RD&I engineers often implement seasonal solvent adjustments, such as slower reducers in summer and slightly faster solvents in winter, to maintain a consistent leveling window. Airflow across the panel is also critical. Excessive air velocity may dry the surface prematurely, while insufficient airflow can create localized pooling and uneven leveling. OEM troubleshooting begins with surface observation under controlled lighting to distinguish orange peel from related defects like stippling, poor leveling, or overspray roughness. Reflection tunnels or side lighting highlight the characteristic dimple pattern and help quantify severity. Once confirmed, the corrective path is multi-pronged. First, verify that the correct solvent blend is used for the current temperature, humidity, and film thickness. Second, confirm that flash-off times match TDS recommendations, with adjustments for environmental conditions. Third, measure wet film viscosity and ensure it aligns with process specifications. Fourth, check spray equipment parameters, including air pressure, nozzle selection, and gun movement. Only after these primary levers are optimized should flow and leveling additives be considered for fine-tuning. In extreme cases where orange peel is locked into a cured film, the only practical remediation is sanding and reapplication under corrected process conditions. Understanding orange peel from this integrated OEM perspective allows plant engineers, formulators, and RD&I specialists to prevent defects proactively rather than reactively. The interplay between solvent balance, viscosity, flash-off, film thickness, temperature, and airflow governs the final surface appearance. Additives serve as tuning instruments rather than corrective miracles, emphasizing that surface texture control is primarily a question of chemistry-process-environment alignment. By following these principles, high-gloss, defect-free surfaces can be achieved consistently, reducing rework, material waste, and customer complaints. If you encounter orange peel issues, have questions about solvent blends, flash-off optimization, DFT adjustments, or additive strategies, please leave them in the comments. Future episodes will address these real-world plant floor challenges with detailed troubleshooting guidance from an OEM RD&I perspective.